So what I want to do is talk about the evolution of big data in hearing healthcare. So I'm glad Katrina mentioned this issue of what is big, because in the hearing aid world and hearing healthcare world, that number has evolved over time. It started pretty small, and now it's growing quite dramatically. So next year, there will be 20 million hearing aids sold worldwide. In advanced countries like with advanced hearing healthcare, like in US, countries in Europe, Australia, about 3% of the population is wearing hearing aids. Each of those hearing aids has data logging in it. They're accumulating, megabytes of data that then get accumulated in clinics for clinicians to analyze the client, their capabilities, and then all of that data gets aggregated up into the cloud by hearing aid manufacturers who's looking at the data from the hearing aid, from the patient's diagnostics, from their demographics, for millions of their hearing aid users in order to improve the product, improve prescriptions, improve the state of hearing healthcare. So big data really touches not only on the hearing aid, but also touches on the patient diagnostic. Perhaps we could call it precision hearing healthcare, to use a term used earlier, but also to do improved audio processing and what people hear. So if we focus on each of these three areas, hearing aids. So we go back to probably the first use of what you might call big data back then. You wouldn't call it big now. But in 2006, the first hearing aid was introduced that monitored usage over time, correlated it with sort of accumulation of acoustic data from the microphones, and learned how the user was adjusting the user controls of the hearing aid, volume controls, push buttons, things that change the settings. So in a way, it was a learning algorithm that was using data on an individual basis over time in order to optimize the use of the hearing aid. Flash forward about a decade, and we now have hearing aids that are wirelessly connected to other products, wirelessly connected to each other. And we have the introduction of a hearing aid that used learning and the accumulation of data on the individual's own voice in order for the hearing aids to learn to identify when the hearing aid wearer is speaking. So it's learning the nature of the person's speech. And in order to do this effectively, it requires wireless communication between the two hearing aids so that they can share data, they can share their information and decision-making on the person's own voice, so it can then adjust signal processing accordingly. That might be differentiated for the person's own voice versus what they want to hear elsewhere. The year after, there was a large introduction by many manufacturers on the use of learning and again, the accumulation of even more data to personalize audio processing for people in different environments. So taking data from the microphone sensors, from the, again, the input that they made, accumulating it across people now, again, using the aggregate data in the cloud in order to optimize settings for users. And this leverages the wireless connectivity between hearing aids and smartphones, and then between smartphones and the cloud. So one example of this is one manufacturer who has an app that in different settings, when it notices different acoustic environments, asks the person to enter preferences for different settings, and you end up with personalized audio processing in the hearing aid, where everyone ends up with something different. So this is an example of different settings for similar environments across different people, showing that there is no common preference for sound quality and speech understanding with hearing aids, and that there is a need for this personalization and use of data in different environments. It's to the point now where hearing aids use geolocation in conjunction with smartphones in order to tell where a person is, and again, use big data in order to determine what might be the best setting for that person in their hearing aid in that kind of environment. Finally, we're seeing hearing aids add non-hearing related features. So for example, a hearing aid that has accelerometers and mini gyroscopes in them to understand the cadence of a person, their motion, detect when they have fallen down, which is a big issue for the demographic of people who wear hearing aids. And machine learning and big data played quite a major role in the development of this technology. Not that it's done live while the person's wearing, but a lot of the training for these systems and the decision making was done with big data and machine learning that then gets embedded in the hearing aid itself. We can also see from this advertisement for one hearing aid that not only do you have detecting falls, you have the ability to track activities with these motion sensors and also translate languages, which of course language translation has relied heavily on big data in order for it to achieve what is really remarkable language translation these days. So that's kind of on the technology side. If we look at the patient and the clinical side, of course, the ability to take data across millions of people and correlate diagnostic data, demographic data, usage data on the hearing aid, and tie it to outcomes as the dependent measure for these machine learning systems in order to determine what produces the best outcome is being done quite extensively now. It's being done by clinicians who take that data log from their clients' hearing aids and make assessments on individual treatments for that client. Of course, the manufacturers are aggregating this across millions of clients and then developing solutions for those clients in the technology that they sell. Big data is also being used for diagnoses. So the first FDA-approved use of machine learning for a diagnostic medical device in the United States was a system that looked at an image of the retina and diagnosed retinal diabetes-related retinopathy, which normally is done by an ophthalmologist who looks at a picture of an eye. Now an AI system can do this with the same accuracy as the best doctor in the world, and all of this because of the application of big data and machine learning for this diagnostic tool. Now, there's a lot of diagnostics that occurs in audiology and hearing, such as looking at the eardrum and determining the health of the person's hearing. So there's a system now that exists on an iPhone that takes an image of someone's eardrum and does what normally an audiologist or an ophthalmologist will do. It diagnoses perforations and other symptoms, other conditions that the person can have for healthy hearing. We also have someone at Macquarie University in it now who has developed new diagnostics that have never been seen before, looking at EEG brain measures and using that as an objective measure of whether someone has tinnitus, which is in fact not a replacement of something that occurs in the clinic, but it's actually the creation of something completely new. We're also seeing the use of big data aggregated across all hearing aid wearers in Sweden in order to try to improve the state of hearing healthcare in that country. So since 2011, over 75% of all people getting hearing aids is having their data entered into a big database. So you can do things like look at how the outcomes of clients varies across different clinics in order to try to identify clinics that are not producing good outcomes and improve them. Also looking for insights such as this, showing on the x-axis the outcome for the patient with their hearing aids, the y-axis the measure of the care that they got from the audiologist, and showing a correlation between the two. So once you understand what produces better patient outcomes with their devices, you can then modify your treatment accordingly. All of this will lead to increased personalization through a variety of mechanisms, through the application of big data, these new diagnostics, and new insights that'll help us understand better how to treat hearing healthcare. Finally, machine learning is having a big impact on the signal processing that is done to improve speech understanding. This is in part leveraging the advances in speech processing that is coming from the massive growth of these voice-first devices like Google Home, Alexa, where incredible advances are being made on speech processing. So a hearing aid was introduced this year, and it was designed by ex-Google and Facebook people who knew nothing about hearing and nothing about speech, simply applied the machine learning knowledge that they knew from these other applications to apply it to improve audio processing for wearers of their hearing aids. So they wear their hearing aids that you see here, they carry around that neural network in their pocket, and the hearing aid will learn over time to optimize the sound processing for that person based on the accumulation of data in that person's unique life experience, but also based on, again, the aggregate data of all of the customers for this company's technology. We've also seen incredible advances in the ability of the application of big data to improve speech enhancement, where you can separate out now individual talkers in the presence of other talkers, which has been probably the hardest challenge facing people who have done speech processing over the past 50 years. And now it can actually be done quite well. And people are theorizing the ability to incorporate EEG measures of brain activity, in order to determine who the person wants to hear, and therefore separate that person out of the audio stream and present that person solely to the wearer of the device, so they can understand the speech better. So to summarize, for hearing devices, we're seeing big data being used to improve the usage of the devices and how to best use new sensors in the devices. We're seeing big data used in how to get to personalized treatment, better diagnoses of conditions, and better outcomes for patients. And of course, we're seeing big data being used to advance audio processing. Thank you.
Thank you very much, Brent. Do we have any questions? Quick one. Not even online? Ah, yeah. Katrina there.
Hi, Brent. Thank you. I know you only touched on this briefly with regard to tinnitus, but are you able to improve people's hearing that have tinnitus?
Yeah, so that's it's kind of a little bit of a black art right now, because right now we don't have great understanding of the mechanism that causes tinnitus. So there are things like maskers that produce sound. They don't really mask tinnitus, but they distract you. Cognitive behavioral therapy is quite successful in getting people to deal with tinnitus. So it's really about managing the tinnitus right now, as opposed to treating it by eliminating it.
So that's something your group is spending time working on and researching further?
Well, certainly the objective measure is a big advancement, because up until now we've relied on people simply stating that they have it with no way of confirming it, which of course has certain issues for insurance and reimbursement if someone claims they have work-related tinnitus, and you have to take their word for it. But being able to diagnose something, to measure something, is the first step in being able to treat it. So this is I think certainly an important breakthrough.
Absolutely. Thank you so much.
Yep.
Okay, thank you very much, Brent.